In the past week, several airline passengers have been severely injured or killed when their flights experienced severe turbulence. On March 1st, 7 people were hospitalized and the plane cabin was left a mess when a Lufthansa flight encountered significant turbulence over Tennessee. A few days later, a woman flying on a business jet was killed when the aircraft was violently shaken and forced to divert to Connecticut. Scientists expect turbulence like this to become more frequent due to climate change. CBS News senior weather producer David Parkinson is here now to explain why. So, David, what does changing atmospheric dynamics have to do with this turbulence?
Yeah, so there's really 3 types of turbulence. Each of them have an important way in which they're going to be impacted going forward. So let's kind of walk you through them here. Here's Air CBS going around right here. And basically, this is an example of clear air turbulence. Notice there's not a lot of clouds in the sky. You're flying through. It should be an uneventful flight, but you're flying with the jet stream here. You're flying right at the edge of the jet stream. So air is moving at one speed at one level, at a different speed at a different. And essentially, they sort of start to back up. So you get these eddies. You get these sort of air-based circles that the plane will fly into and potentially can drag it down in one direction on the other side, up in the other. And that's how you can get the kind of clear air turbulence that you've seen on that Lufthansa flight. It was not flying through a storm, and in fact, it was just moving through clear air. So that's option one. Another one is if you're flying around a thunderstorm system. So in this case, you can kind of see the clouds here. There's all kinds of updrafts and downdrafts of air pockets that are coming in association with those things. And as these storms get more violent and more intense, the height that they exist at actually increases too. So you can't necessarily fly over them. And the good news is you're flying through clouds, so you see it coming. The bad news is they can be exceptionally violent. And then the final one, this is an interesting one. This is actually if you're flying through any sort of mountain ranges. So right here, I've set the map. This is the edge of the Rockies. You get the Chinook winds coming down. It speeds up as it comes down off of the Rockies, but you also get sort of more violence in the air around it, and it takes a while to smooth out. So if you're flying over the Sierra, the Appalachians, the Rockies, you'll tend to experience some turbulence there as well.
So those of us who've flown over those ranges know that. That feels like something we've always experienced.
Correct. That's right.
The clear air turbulence, just to grasp hold of the completely obvious here, as you said, is you can't see it. I mean, those thunderclouds you mentioned in your second example, at least you can see those. Right. But with clear air, there's no visible evidence that it's coming.
Yeah, so this is what we call the PIREP reports. These are all the reports of turbulence the pilots are giving us right now. And so you've noticed that we do have some weather down here in Texas. Not too many reports. We've got some weather up here in the Midwest. Not too many reports. But look at all of these reports in the Vegas area. We've got another one down here by Miami. This is one of the few days Miami doesn't have thunderstorms. These are all examples of pilots going right around where the jet stream is. And so as a result, you are seeing clear air turbulence depicted on a map just like this.
Oh, and that feels like when the pilot comes on and says, put your seatbelt on, we've been getting reports.
Correct.
That would be
exactly
those
what
reports.
It is. So that's one of the ways that pilots can know going forward that you're going to be hitting those rough patches. We also have some interesting algorithms that we're putting together with radars and models that can help to predict it, but there's no substitution for knowing it's coming because another plane's already gone through it.
This is incredibly nourishing. Okay, now, final point. You already touched on this a little bit, but as weather gets more severe because of climate change, that creates more tricky problems for flying, right?
Yeah, so this is an example of where we're going to see more turbulence. So there have been studies that have predicted that there's going to be anywhere between 40 and 300% more turbulence in the next half century. And the reason for that is on the transatlantic routes. So if you've flown over to Europe, you'll usually fly on a path that's something along the lines of like that. That's usually the way we go. Over the last couple of years, we've had record fast flights because the jet stream has been super amplified. This is an example of a place where we know climate change is having an impact. Because you're having the temperature difference become a little less extreme between the poles and the center of the world, you are seeing the jet stream do more waves. You're going to see it be a little bit more unpredictable. And so as that happens more and more often, you get these disturbances right at the edge of the jet stream that you have to fly through. So if you'd expect maybe 10 minutes or 20 minutes of turbulence right now, you might get 40 minutes or an hour of turbulence as we go further into the future. The key thing that I want to kind of point out here is you're most likely to experience turbulence during the winter on these big, long transatlantic routes. They haven't studied Trans-Pacific, but I'd imagine, the jet stream goes all the way around the world, so I'd expect we'll see that there as well. But the other thing to note is that during the day over land masses, you will see it there as well. So early in the morning, late at night, and not over the oceans is your best place to see less turbulence.
And in the summer, right?
And in the summer,
In the summer. We get travel tips and we learn about the weather. David, thank you so much.
Thanks.
Appreciate it.